So how is your day today?
Fine, thank you.
Very well. Feeling very happy today. So today we'll be looking at Hooke's law. We'll be looking at Hooke's law. Hooke's law. I don't know if you can remember in our previous lesson where we talked about force, we talked about masses, and then we said that weight, a body that has weight, the weight is like a kind of force. Okay? And every matter has weight, and weight itself is a force. Now, we want to extend this knowledge for some bodies that are elastic in nature. Bodies that are elastic in nature. Okay, when something is elastic, what do we mean? We mean a material that when you stretch it, it can return to its original size. Okay? The stretch can turn to the original size. Like this your rubber band you play with. Okay, that's an example. Okay, of something that is elastic, you stretch it turns back to its original size. So we have what's known as Hooke's law, and then let's take the definition of Hooke's law first before I explain further. So you can write. Hooke's law states that the extension of any elastic material is directly proportional to the applied force, provided the elastic limit of the material is not exceeded. Before we move further, I want us to look at some of the objectives that we learned. We'll be looking at Hooke's law, like I said, stating Hooke's law. We will identify different apparatus used to verify Hooke's law. We may even carry out an experiment to verify Hooke's law, and then solve calculations based on Hooke's law. Okay? Like I said, Hooke's law states that the extension of an elastic material is directly proportional to the applied force, provided the elastic limit of the material is not exceeded. So what do we mean? If we look at this, I have a stand here, and then I have a string. Okay? So this string you have here is an example of an elastic material. Observe what is happening. As I stretch it, and I release it, as I stretch it, I'm applying a force. But the moment I release it, what happens? It returns back to its original size. So this material, this spring, is an example of an elastic material. So let's say, for instance, I have a mass that I apply. Look at what I have here. These are different masses combined here. Let me remove them. I have different masses, and these masses have different values. They have different values. For instance, this one is 20 grams. This one is 50 grams. So if I want something that will give me 40, I will take 220 and I'll join them together. If I want something that will give me 70, I'll take 150 and then 120. I achieve 70 like that. So depending on what you want. Now what I have here is called a mass hanger. This is my ritual stand. So all these are the apparatus that we're going to use to verify Hooke's law. The last one is this one here, called the meter rule. The meter rule. So we use it for measuring length. We use it for measuring length. Now, according to Hooke's law, what Hooke's law states is that the force is proportional to the extension. That means the more the force, the more the extension. Like here now, the more force I apply on this, the more it will extend. Okay? Now, how do I determine the extension? The extension is the difference between the final length and the original length. Okay? So, for instance now, I can take my meter rule and I place it very close to this string here to get the original length of this. How do I get the original length of this? Well, for my meter rule, I will check where does this thing tally? Where does the position, the tip of this tally? From what I can see, it's starting at 52 on the meter rule. So since it's starting on 52, I will look at the bottom here, where the lowest point is here, and I'll mark it again. And from this, I'm seeing that it is 61. So the length of this is going to be 61 minus what? 52. 61 minus 52. That means the original length, let me call LO. LO will represent original length here. So we said 61 minus 52. Somebody help me. 9. What would that give me? 9. So since I'm taking my measurement in centimeters, this becomes 9 centimeters. Are you with me?
Yes.
Okay? Now, if I want to convert this to meter, what do I do? From primary school, you are taught to convert from centimeter to meter. What do you do? Divide by 100. So in meters, this will give me 0.09 watts meters. Is that clear? Now, this is the original length, L0. Now, let's say I want to take another length now of this. And I apply my hanger. And then I apply a mass. Let me pick this one that is 50. And I put the 50 there. And I put the 50 there. What will you observe? Can you see that my spring has extended in length?
Yes.
Huh? It has extended in length. Now I can take my ruler, my meter rule rather, and take the measurement again. Ordinarily, the one at the top is 52, right? Yes. So I will mark where the end of this spring is, which is somewhere around here with my finger. If I remove it again, I'm seeing 65. I'm seeing, or can somebody come and look and verify? You can see from that end better. From the tip of where this one is, what is it marking at? Because to avoid error to parallax, you know what I when you stand and look at it, you may not get an accurate value like that. Just for estimates, yes? 62.5. Can another person come and verify? Another person, please come and verify. Your eye level should be at the same level at the point you want to measure. That way you avoid error to parallax. Bring your head down. Bring your head down. No, yes, you should be parallel. Your eye should be parallel to this lower point here. So put your eye on this level. Bend down very well. You should kneel down, kneel down. Your head is still high. Bring your head down. 62. So you got 62.5, you got 62. Okay? One more person should come and break the dice for us. This lowest point here, what is it starting with? 62. Bring your eye down to eye level. 62. Are you sure 62 or you are saying 62 because she's your friend?
No.
She's 62. Okay, let's work with 62. We have 262. So that means in this case, our new length is what? 62, right? So 62 minus the original length of what? 52, right? What's the difference? 10 centimeters. So which is the same thing as divide by 100. That will give me 0.10 meter. Is that clear? Can you notice that we can now get the extension in this case? And then my extension, the formula for extension is what? Final length minus original length. Which will give us what? My final length is what? 0.10 minus what?
0.09.
0.09. That will give me what? 0.01 meter. That's the extension in this case. So, before we got this extension, we had a particular length. After the extension, after the application of the mass, we now got the extension. That is what Hooke's law is trying to say. Okay, that the more the force applied, the more the extension will get. And the formula for this, F is proportional to E, we can extend it because this is a proportionality symbol. From what you learned in mathematics, the force will now be equal to the constant. In this case, let's use K for the constant. Okay? The constant times what? The extension. So this is the formula we can use to solve any question on Hooke's law. So, for instance, let me give you a simple question. You can take it down. Determine the force, right? Determine the force applied on an elastic material. Determine the force applied on an elastic material of stiffness 5 Newton per meter and an extension of 0.2 meter and an extension of 0.2 meter. Determine the force applied on elastic material, of stiffness 5 Newton per meter and extension 0.2 meter. Now, in solving this question, stiffness is the same thing as the constant, so take care or take note. Sometimes they may call it stiffness, sometimes they may call it the constant of the elastic material. They are saying the same thing. So the force applied according to the formula is equals to the stiffness K, right? And what do we say our K? 5 times our extension 0.2. So the force applied thus becomes what? 1 Newton. 1 Newton. Okay? 1 Newton. So do this question for me. Similar to this one, we'll just change some parameters. Determine the elastic constant of a material. Determine the elastic constant of a material if the force applied is 20 newtons. If the force applied is 20 newtons and the extension is 0.3 meters and the extension is 0.3 meters. So who has the answer for me?
66.6.
Huh?
66.6.
66 point what? 66.6. Okay, let's see if she's correct. Who agrees with her?
66.67.
4.6. What are we looking for? We're looking for the what?
For the K.
For the constant, right?
Yes.
For the constant. So if I'm looking for the constant, you know our formula is F is equals to what? KE, right?
Yes.
So making constant is equal to the what?
Formula.
We have K is equals to what? F over P. And our K is equal to force. What's the force? 20. What's our extension? 0.3, right?
Yes.
That will give me what? That K. That will give me that K is equals to what? 66 point what?
67.
Now, this is where you will get half of the mark. You told me 66.67, but you did not give me the SI unit. Newton per meter. Don't forget. Even if you forget in the exam, remember that from the formula you can always get the SI unit. Look, the elastic constant of stiffness is force over extension. And force is measured in what? Newtons. While extension is measured in what? In meters. Are you getting it? So that is why the unit is what? Newton per meter. Okay? Newton per meter, that's the extension. Okay? Is that clear? Do you have any questions? Yes? It can be measured in centimeters. The only thing is just that why we stick with meter is because meter is the standard unit for what? Measurement of length. However, there are some questions where they may use centimeter instead of meter. And then when they say Newton per centimeter. So if you see a question, like an objective question, if the answer is in Newton per centimeter, stick with it. But in most cases, they expect you to convert to meter because meter is the standard unit for what? Measurement. Is that clear? Okay? Can somebody give me one more example of an elastic material apart from the ones I've mentioned so far in class? Huh? She said zinc. Is she correct? Huh? Is she correct? You don't think so? Huh? Do you know that concrete, like this wall, can be an elastic material? Wood can also be an elastic material. Eh? So, because when you apply a force on concrete like a block, it expands. The extension might be small. It extends. Let me not say expand. It extends. The extension might be very, very small, but it's there. That is why civil engineers, before they build a house, the civil engineers will calculate the amount of weight that will be placed in that building. Okay? The amount of weight must not exceed the stress that the building can handle. So the more load they apply on it, the more load that is applied on a building, the more the building will extend. That is why sometimes you will see some buildings, they will crack. So what's making that crack is that the force applied on it is so much that it's making it to start extending and going beyond the Hooke's law limit or the elastic limit. So your concrete, your wood, these materials, they extend when the right force is applied on them.
So when they restore like
yes, even this building we are in now, as we have load acting on it, it will extend and return back to the original side. However, the moment they start cracking, when the load that is applied is more than what is known as the elastic limit, at that point, it will no longer return to the original side. It can even break and crack. But up until the point where before it breaks or crack, it can return back to the original size. So once you are in a building, you are applying the force on a building, maybe you climb upstairs, you are there, you are part of the force, your table, your chairs, they are part of the force on the building. It's making the building to extend. It may not be so visible to you with the human eye, but it's actually extending. And if the force is much, it will eventually crack or break. Is that clear?
yes.
Okay? So we'll continue from there in the next class, where we'll look at other aspects related to this topic. Okay? So have a nice day.
Thank you, Mr. Ike, for imparting your knowledge on us. Remain blessed and stay safe.
Thank you very much. Okay? So you can take this to the lab and bring it home.